This page of notes is so that we can understand the idea of what we call reference angles and how we can understand the concept of every time we have one angle on the unit circle, there's actually four angles that have the same cosine, sine, and tangent. The only thing that might differ is the positive and negative as far as the sign of the cosine, sine, and tangent. So let's start off with this 35-degree angle. So what we're going to pretty much do on all of these unit circles is we're just going to draw, oh no, I just did a really bad job of drawing that. We're going to draw this X, and we're going to find the four angles that all have the same cosine, sine, and tangent. Now the 35-degree angle means that 35 degrees would be in the first quadrant, so I've given you the first quadrant, which means if this is a 35-degree angle, all angles on the unit circle are measured in terms of the horizontal. So everything is measured in terms of this horizontal line, not the vertical line, the horizontal, which means this is a 35-degree angle, this is a 35-degree angle, and this is a 35-degree angle. 35 degrees from the horizontal. Well, we know that this is 0, so 35 degrees from the horizontal gives me 35 degrees. I know that this right here is 180, and I'm 35 degrees up from that horizontal, so I'm going to, in my calculator, put 180 minus 35, and I will get 145 degrees. So if right now you were to put in your calculator, let's go ahead and do it. We're going to move to our calculator, but what we're going to do, I'll just explain before we go to the calculator. We're going to look at 35 degrees. We're going to look at the cosine of 35, and we're going to look at the cosine of 145. Now the only difference would be, since this cosine over here is negative, same number, but it should be negative. The sine of 35 and the sine of 145 should be the same, both in number and in sign. And then the tangent of 35 and 145 should be the same, except over here it's going to be positive and over here it's going to be negative. I just want to show you that that's actually true. So I already made sure that my calculator was in radians, and when I find the cosine of, 35 degrees, here's the number I get. Now when I move over to quadrant 2 and I do the cosine of 145, it's going to be negative because it's in quadrant 2 and my x-coordinates on that left side are negative. And look at that, same number, just a negative. All right, let's go back to our unit circle. Okay, so then this angle here is 35 degrees past the 180, so this is going to be 180 plus 35 degrees, which is going to give me 215 degrees. And then over here, since all the way around the unit circle is 360, and I'm not quite to the 360, this is going to be 360 minus 35. It's 35 degrees before the 360, and I get 325 degrees. And what I want to show you again, we're going to go to the calculator. I want you to see that the cosine of 215 is going to be the same number and the same sign as this one, and the cosine of 325 is also, and I'm just using cosine, we could use sine or tangent, I just picked cosine as an example. I want you to see how they're all the same. So we're going to go back to the calculator, all right, and cosine of 215 degrees, look at that, and then cosine of 325. So as you could see, based on what we found on the calculator, all four of these angles are going to have the same numbers as far as, just the number part, as far as cosine, sine, and tangent, but their signs are going to be different. Of course, cosine, sine, and tangent will all be positive in this quadrant. cosine will be negative, sine will be positive, tangent will be negative in this quadrant, etc. So as we move around, whether they're plus or minus is going to change, but the actual numbers will be the same at all four of these angles. All right, so let's look at 110 degrees. So I'm always just going to draw my x, and then what I've got to figure out is the 110, which quadrant is the 110 in? Well, I know this is 0, this is 90, this is 180, so the 110 must go here. Now again, you have to remember my reference angle is in terms of the x-axis. So I need to figure out what this angle here is. Well, this is 180 and this is 110. This is 70 degrees up from the 180. So this must be 70 degrees, which makes all of these 70 degrees. All of these angles have to be the same. Well, that makes this 70 degrees. This is 70 degrees past the 180, so 180 plus 70, I get 250 degrees. And this is 70 degrees before the 360, so 360 minus 70, that's going to give me 290 degrees. If you were to do sine, cosine, or tangent of any one of these four, they should all be the same. All right, let's go to my next one. Again, I need to figure out where does that 235 go? 0, this is 90, 180, 270. It must be here between the 180 and the 270. But again, I've got to figure out what my reference angle is, or that angle that is between the line and the horizontal. I know that I have to figure out how far past the 180 am I. I know that I'm past the 180, so I'm going to take 235 and subtract 180, and I get that I'm 55 degrees. This is 55 degrees, which makes this 55, this 55, and this 55. They all have to be the same. So this is 55 degrees. Well, then I know that this is 55 degrees before the 180, so 180 minus 55, and I get 125 degrees. This is 55 degrees before the 360, so 305 degrees. Okay. All right, let's do one more, and then we're going to look for patterns. Okay. Remember, math is all about patterns. All right, 320, I've got to look at this. This is 90, 180, 270, 360, so the 320 must be here. Again, I'm looking for its distance from the horizontal. So how far is this distance here? Well, this is 360. So 360 minus 320, this must be 40 degrees, which means this is 40, and this is 40, and this is 40. They all have to be the same. So this is a 40-degree angle. This is 180, so this is 40 degrees before the 180. So 180 minus 40, I get 140 degrees. This is 40 degrees past the 180. So 180 plus 40, I get 220 degrees. Okay? All right, so let's look for patterns, because this will be much easier once we understand what the patterns are. For instance, I want you to notice that if you look in the top two quadrants, these add up to 180. 145 and 35 add up to 180. 110 and 70 add up to 180. 125 and 55 add up to 180. All right, 140 and 40 add up to 180. The other thing I want you to notice is that when we go along a straight line you should have learned in geometry is 180 degrees. 35, go across the straight line, add 180, you get 215. 145, add 180, it's a straight line, you get 325. 145 and 180 is 325. If you go the opposite direction, you subtract 180, you get to 35. You subtract 180, you get to 145. So the fact that this is a straight line in 180 degrees is really helpful. The other thing I want you to notice is that these two always add to 360. 35 and 325 add to 360. 145 and 215 add to 360. So as we go along these straight lines, we're either adding 180, subtracting 180, adding 180, subtracting 180, add to 360, add to 360, and these two always add to 180. That works on every one. Let's look at this one randomly, right here. Add 180, you get to 220, subtract 180, you get to 40. These add to 360, add to 360, add to 180. That's my patterns. So, as we fill in the next three, let's think about those patterns, and it might make it a little easier for us. I always have to first figure out where does this angle go. 118 will go here, because this is 90 and this is 180. Now remember, as I go along here, this is a straight line, and I'm getting bigger, so I add 180. That gives me 298. All right. Then I have to think, I need these two to add to 180. So I can think 180 minus 118. That gives me 62. And that's always, my first quadrant answer is always my reference angle. The reference angle is the angle that we repeat in all four of these. And remember, everything is in terms of the horizontal. To find this one, I'm going across the straight line, so I add 180 and I get 242. Right. See if you can fill in these final two without any assistance from me. So I'm going to go ahead and do this just in case. But you could always fast forward after you've tried it to see if you get the right four answers. The 228 is going to go in this spot here because it's before 270. All right. I know this is a straight line and I'm getting smaller, so I subtract 180. 228 minus 180 is 48 degrees, which makes all of these 48. All right. I know these two have to add to 180, so I take 180 and subtract 48, and I get 132 degrees. This I'm going to go across a straight line that's 180, so I add 180 and I get 312 degrees. Okay. The last one here, the 295. I'm going to draw that X. $295. Let's see. I know this is 270, so this must be 295. All right. I know that these two, well, first of all, I guess the easiest one is go this way, straight line, but I'm getting smaller, so I subtract 180, and this is 115. And I can either think to myself that these add up to 180, or these add up to 360. Either way, I can think to myself 180 minus 115, or I can think 360 minus 295. Because I know these add up to 360. Either way, I get 65 degrees. They both give me 65. This straight line, add 180, and I get 245 degrees.